Hey guys, welcome to the 16th episode of Static Timing Analysis. We are continuing hands-on practical using OpenTimer-STA. Today, we will dive into the what-if-then analysis combined with gate sizing through OpenTimer-STA. Stay tuned till the end of this episode for enhancing your knowledge on hands-on static timing analysis.
Hey guys, welcome back. We are in our computer screen. For today's episode, we will download one particular test case from OpenTimer website. So let's go there. So this is our OpenTimer website. The first result which has come. Let us go there. And let me scroll down to the examples. So in today's episode, we will be experimenting with this particular test case, timing driven optimization example plus incremental timing update. We will be downloading the optimizer test case. So here the path is ready. Let me copy it. Here we are ready with the terminal and we are in the OpenTimer test case directory. So let me type chclone. Here I pasted. Let the test case clone. Meanwhile, let me tell you why I have kept 3 terminals. In the first terminal, I will do up to a certain point and stop there. In terminal 2, I will proceed with some further step till the end. And as usual, the third terminal will be our Unix terminal where we will do our Unix stuffs. Our test case is copied. Let us go into the directory. So I will be doing the same in the next terminal. 3 different terminals. We are in the same folder, that is OpenTimer test case /optimizer. So let me do a ls. So you can see there are several files are there. You are already familiar with this file extension and how we load these things. So for today's episode, I have made one shortcut, easy to use flowchart in text so that I can move faster instead of typing. So let me display it. This is Steps.txt I have created. I'll come to it later. First, let me launch the OpenTimer shell. In the first one and in the second one. The OpenTimer shell has been launched in the first 2 terminals as I mentioned. Now let me clear the screens. The screens are clear now. Now here there are 2 libraries are there in the test case and we are analyzing using both of them, and let's have a diff between them. So for that we are using the tkdiff command. Also you can take a gvimdiff command. Let the tkdiff open them. And as you can see that early is used for hold analysis and the late timing lib is used for setup analysis. So here is our tkdiff. It has opened. You can see here library early and library late, and if I scroll down you can see the tkdiff has been highlighting the difference point. So early is here for the hold and late is for the setup. You can see the changes are there in the lookup table. You can see in the left and the right. So here you can see how these 3 this 1 2 3 these things are different. Obviously subsequent things are also different. Here you can scroll down and see the differences, and tkdiff is highlighting everything in detail. So this way, is only the LUT segments. The different LUT segments are different in between these two libs. So let me close it. You can browse and explore by your own. In case you don't have the tkdiff command, I'll provide the tkdiff installation command for Ubuntu in the description. So let me close it. So here let me quickly load the files. Today I'll take the shortcut here using my Steps.txt. So here for the first terminal, we have made the terminal ready to continue our experiment. You can see here it is written added min cell lib as early and added max cell lib as late. So it has picked up two different libraries, min for the setup and the hold part, and the command that we have used, that read cell lib early, we give the early.lib, and we give the late flag, and then we give the late.lib. So let me do the same thing here in the second terminal. So folks, again the second terminal is ready also, and let me just clear the screen. Before clearing the screen, I would like to pin this particular output pin, that is the endpoint G17. You can remember this one because later we will be experimenting on this particular pin. Let me clear. So since both are same, let me do this max analysis in one shell, means analysis in the another shell. I was just speaking about this G17, right? G17 is coming here. Again we have G17. Okay. Similarly for this case, for the mean analysis here, also going through here. Here this endpoint is different. So here we just flashed two different commands for mean and max analysis, and there are violations in both of them. That means we have the setup and hold both kind of violations in this particular test case. So let me clear the screen. So we are done up to this point. Now comes the part where I will do up to some point and then I'll stop there, as I mentioned for terminal 1. So here what I'll do, tns wns this one, report slack has been done, report 80, report rat. We already done this report timing, so I'm not going in this particular command. So I'll come to this command, not right now, later I will come. So here I will pause for this terminal 1 and I'll move on to terminal 2, where what I will do is I'll execute the next steps. So here what we can see in the Verilog file, if we open up, there is an instance 10, and for this case we will be using the repower get, which I have already explained in past episode. Here we will do the get sizing here for this particular instance from the Verilog file, and let me do it. We have done. So terminal 1 remains unchanged, and in terminal 2 we are doing the changes. We will do some what if then steps. So these things I have explained to you when I was describing the OpenTimer manual, where I also explained the timing reports theoretically through the slide. In the same episode I have this what if then cases. I'll also provide the link in the description of that particular episode so that you can go and see in detail. So here we'll insert a buffer into the design, and its syntax is insert get. Then the next field, this is the command insert get. The next one is that get instance name, the instance name where we are inserting, and the library cell name. Library cell name means the name which is there in the, at least in the .lib file, here whatever files are there. This goes our first what if then command. So then we will insert a net to connect. It's a simple command. Execute it, and we are done the entering the buffer, and then what we have done that we have insert the get, and then we have insert the net. And from Verilog we can again see that there is a instance 3 for nor get. So what we will do with that, we will disconnect the pin Zn, you can see this Zn, and rewire it with the new net that we have defined. So tau net 1 which we have defined. So we will rewire this particular net with this particular pin. So the syntax is, first thing we will disconnect and then we will connect using these two commands, and the syntax is disconnect pin, then the pin name, and connect pin, then pin name. So we first disconnect this particular pin, and then we connect the pin. Fine. So these steps are done. Now let's connect the newly inserted buffer in between the tau get 1 and net underscore 14. So tau net 1 you are already inserted the net, and tau get 1 and net underscore 14. So you can see net 14 here, net 14 is here. and tkget1. Here we have already used tkget1. So let's connect the inserted buffer in between tkget1 and net14. For that we are using the connect pin command here. And the second connect pin command. So you can see that A and Z are the two ports of the buffer. You can easily identify here and here. These two are the two ports of the buffer. Now in the test case it is already there ready, the spef file. As we have done the changes in the net, right, definitely the parasitics will change and the corresponding spef is also supplied in the test case. So we will take the difference of the before and the after spef using the tkdiff command. Let me do the tkdiff. You can see that in the dnet connection here net 14 is there, it's changed, tkget1 has come here. So this way you can see multiple changes have been introduced in the original, the optimizer.spef and the change spef. Here the name is change_1.spef. So these two you can see here the difference, and if you keep on scrolling down you may see some more changes if it is there. Yeah, here it is. Here you can see the changes. And here is 2. So the change is very much evident. I'm not going in details. I've done a complete episode on spef. I'll provide the link in the description in case you want to see and explore by yourself. Obviously you can go ahead and do that. I'll close this tkdiff window and here. So we have done this up to this point, connecting this one, you can see. Now let us add this particular spef. We have done the change in the spef. Here what I will do, I'll do a report timing. You can see whatever changes we have done, it has incorporated the changes, it has loaded the spef and added the nets. Let me clear the screen. The first terminal was paused at this point. The second terminal we have moved up to a certain changes. Now let me print out these things in terminal 2. You can see now the result has come. So here, so we cannot see any particular changes using this particular command. We'll move on to the next step. We'll use the dump slack command in both of them. Okay, here and here. What I'll do, copy the output up to this point and paste the entire thing here in the slack before.txt. Come to terminal 2 here. I copy the entire thing. And I paste in the another file that is named slack after.txt. I save the file. Now let me take a tkdiff in between the two. So folks, when we finally use the dump slack command, we can see the significant difference. You can see the before.txt is in the left side and the after.txt in the right side. So this is from the left side pane and this is from the right side pane. You can see there has been a lot of change here in these columns: early rise, early fall, late rise, late fall, early rise, early fall, late rise, late fall. So all these columns you already know. You can see there is a significant change in the overall Slack report, which has got impacted because we have done, these are end slacks. So whatever you can see, these are end slack for all these pins, and since we have inserted a buffer and we have repowered a gate, it has impacted whatever nodes were around it. So this way all these 4 branches of slacks are affected. So you can see it has impacted this timing what if then analysis and the repowered gate analysis we have packed together in this particular example. Folks, we have come to the end of this episode. I'll close it. Thank you for watching up to this point. Don't forget to like, share and subscribe. In case you have some dislikes, put that as in words in the comment section below. And bye for today.